Chapter 10 Space Missions. Introduction. Man has always been curious about unknown places, and he has always been eager to expand the horizons of his knowledge by exploring the unknown world. Man not only has curiosity about the unknown places on the earth, but also about the unknown places around the earth. He must have had deep curiosity about the space and the many twinkling stars in the dark sky. He must have had dreams to fly to the space and must have been working for that. In this chapter, we are going to study about the space explorations done by man to quench his thirst of knowledge. In the previous grade, we have studied that the portion of the Earth's atmosphere and the portion beyond that, which can be seen in the form of a roof by our eyes while standing on the earth, is called the sky. Whereas the continuous empty space between the spheres, like that of planets and stars, etc. in the sky, is called space. It may contain gases and dust particles. Numerous star clusters have formed in space. Out of all the different groups of stars, our solar system consists of the Sun, 8 planets and their satellites, dwarf planets, comets and asteroids. Do you remember what is meant by satellite? The celestial bodies that revolve around a planet without independently revolving around the Sun are called satellites. Moon is the only natural satellite of the Earth. Man has stepped onto the moon. Also, he has sent some spacecrafts for collecting information about the unknown facts in the universe. Come then, let us now study how this has become possible. Missions. In the later half of the 20th century, substantial developments in technology, especially space technology, happened. This resulted in the development of spacecrafts, making space voyage possible. Since then, more than 1,000 artificial satellites have been placed into orbits around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. We shall learn about various space missions in this chapter. The space missions can be classified into 2 categories. In one type of mission, the objective is to put artificial satellites in orbits around the Earth for research and various other useful applications. The objective of the second type of mission is to send the spacecraft to outer space for close observations and understanding of the objects in solar system or even outside the solar system. Do you know? The first person to go into space in a spacecraft was Yuri Gagarin of the then USSR. He orbited the Earth in 1961. The first person to step on the moon in 1969 was Neil Armstrong of USA. Rakesh Sharma of India orbited the Earth in 1984 in a Russian spacecraft. Kalpana Chawla and Sunita Williams of Indian origin also participated in space explorations through missions organized by NASA, that is, National Aeronautics and Space Administration of USA. In the previous grade, we have already studied about the various types of telescopes orbiting around the Earth. Can you recall them? Yeah, right. Some of the important telescopes which are active in space include optical telescope, gamma-ray telescope, X-ray telescope, telescope receiving ultraviolet rays, infrared telescope, microwave telescope, radio wave telescope, and the telescope receiving the gravitational waves. Come, let us now answer few more questions. We all make use of cell phones nowadays. It has made our lives simpler. We can easily contact a person staying at a distance. But have you ever wondered, where does the signal in your cell phone come from? Where from does it come to the mobile towers? We all love to watch TV. We are even able to see the live telecast of the matches being played in other countries. How does this become possible? Where does the signal to the TV come from? While reading the news, you might have seen photographs showing the position of monsoon clouds over the country in the newspaper. How are these images obtained? All these become possible with the help of satellites. As we have already learned that, along with the natural satellite, there are many artificial satellites orbiting around the Earth. An artificial satellite is launched into space for a special purpose through space missions. Come then, let us now study the need and importance of space missions in the coming part of this chapter. Need and importance of space missions. Many artificial satellites have been launched in space, due to which the world has become a global village. Today, we can contact a person in any part of the world within a second. The information about worldwide events can be gathered sitting at home. Internet is of very much importance in today's world. Due to Internet, every information is available at our fingertips. It has become possible to get advance alerts about natural calamities and take proper precautions. During war, it is possible to get information about the actions of the enemy through aerial surveillance using satellites. It is also possible to explore the fossil reserves and minerals in the Earth. Thus, there are unlimited applications of space missions. Today, space technology is an inevitable part of the development of a nation. Come, let us now know about artificial satellites. Artificial satellite. In our earlier grades, we have learnt about natural satellites. An astronomical object orbiting the Earth or any other planet is called a natural satellite. The Moon is the only natural satellite of the Earth. Some other planets in the solar system have more than one natural satellite. Similarly, if a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called an artificial satellite. The first artificial satellite, Sputnik, was sent to space by Soviet Union in 1957. Today, more than 1,000 satellites are orbiting the Earth. Satellites work on solar energy. So, solar photovoltaic panels are attached on both sides of these satellites like wings. Instruments are installed in the satellites to receive the signals from the Earth as well as to transmit signals to the Earth. Satellites have various other types of instruments depending on their functions. One such satellite is shown here. Signals transmitted from the Earth to the satellite and from the satellite to a mobile tower and mobile phone are also shown. These satellites are sent into space to perform various functions. Depending on their functions, satellites are classified into different categories such as INSAT, that is, Indian National Satellite, GSAT, that is, Geosynchronous Satellite, IRNSS, that is, Indian Regional Navigation Satellite System. IRS, that is, Indian Remote Sensing Satellite. GSLV, that is, Geosynchronous Satellite Launch Vehicle. And PSLV, that is, Polar Satellite Launch Vehicle. Let us now study about some types of satellites and their functions, as well as the names of their Indian satellite series and their launch vehicles. The weather satellite studies and gives predictions of the weather. The Indian satellite series INSAT and GSAT are used for weather satellites, and the launcher used for them is GSLV. The communication satellites establish communication between different locations in the world through the use of specific waves. INSAT and GSAT series satellites are used for this purpose and are launched by GSLV. Telecasting of television programs is done with the help of broadcast satellites. Broadcast satellites are of the INSAT and GSAT series and are launched by GSLV. The function of navigational satellite is to fix the location of any place on the surface of the Earth in terms of its very precise latitude and longitude. Navigational satellites are of the IRNSS series and are launched by PSLV. The military satellite is used to collect information for security aspects. The Earth observation satellite is used for the study of forests, deserts, oceans, polar ice on the surface of the Earth, as well as for exploration and management of natural resources. This satellite is also used for observation and guidance in case of natural calamities like floods and earthquakes. This satellite comes under the series IRS and is launched by PSLV. Now that we have studied the different types of satellites and their functions, we shall proceed further to learn about the orbits of artificial satellites. Orbits of artificial satellites. There are many artificial satellites revolving around the Earth, but all of them do not revolve in similar orbits. The height of the satellite's orbit from the surface of the Earth, the circular or elliptical nature of the orbit, and whether the orbit shall be parallel to equator or making some angle with it. All these depend upon the function of the satellite. The satellite is taken to that height using a satellite launcher to put the satellite in its proper orbit at a specific height above the surface of the Earth. Then the satellite is given a specific velocity known as the critical velocity, that is, VC, in a tangential direction to the orbit. Then the satellite starts revolving around the Earth. Do you know how can the critical velocity be determined? Come, let us know about it. If a satellite of mass m is revolving around the Earth in an orbit of height h with speed vc, then a centripetal force mvc square upon r acts on it. Here, r is the orbital radius of the satellite from the center of the Earth. This centripetal force is provided by the gravity of the Earth. Therefore, centripetal force is equal to gravitational force between the Earth and the satellite. This equation can be written as mvc square upon r plus h equals to capital G into capital M into small m upon r plus h the whole square. Therefore, vc square is equal to capital G into capital M upon r plus h. Therefore, vc equals to square root of capital G into capital M upon r plus h. This is equation 1. Here, G is the gravitational constant, which is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. M is mass of the earth, that is equal to 6 into 10 raised to 24 kilograms. R is radius of the earth, and its value is 6.4 into 10 raised to 6 meters, which is equal to 6,400 kilometers. H is the height of the satellite above Earth's surface, and R plus H is the radius of the orbit of satellite. From this equation, it can be seen that the critical velocity does not depend on the mass of the satellite. As the height of the satellite's orbit from the Earth's surface increases, the critical velocity decreases. Depending on the height of the satellite's orbit above the Earth's surface, the orbits of the satellites are classified into 3 categories. Come, let us study about them. High Earth orbits. Height from the Earth's surface greater than 35,780 kilometers. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 kilometers, the orbit is called high Earth orbit. A satellite revolving in an orbit 35,780 kilometers above the Earth's surface will take around 24 hours to complete one revolution. We know that the Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of rotation of the Earth around itself, and that for the satellite to revolve around the Earth being the same, the satellite will appear to be stationary with respect to the Earth. If a passenger is sitting in one vehicle and another vehicle is moving parallel to him with equal velocity, then that vehicle appears to be stationary to that passenger. The same happens here too. These satellites are therefore called geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. Therefore, they are used in applications like meteorology and for carrying signals for telephone, television, radio, etc. Medium Earth orbit. Height above the Earth's surface 2,000 kilometers to 35,780 kilometers. If the height of the satellite's orbit above the Earth's surface is between 2,000 kilometers and 35,780 kilometers, the orbits are called medium Earth orbits. Geostationary satellites orbit above the equator. These are therefore not useful in the study of polar regions. For this purpose, elliptical medium Earth orbits passing over the polar region are used. These orbits are called polar orbits. In these orbits, the satellites complete one revolution in 2 to 24 hours. Some of these satellites revolve in circular orbits at a height of about 20,200 kilometers above the Earth's surface. Global positioning satellites revolve in such orbits. Low Earth orbits. Height above the Earth's surface 180 kilometers to 2,000 kilometers. If the height of the satellite's orbit above the Earth's surface is between 180 kilometers and 2,000 kilometers, the orbits are called low Earth orbits. The satellites used for scientific experiments and atmospheric studies revolve in low Earth orbits. Depending on the height of their orbits, they complete one revolution in about 90 minutes. International Space Station and Hubble telescope also revolve in low Earth orbits. Satellite launch vehicles. Satellites are placed in their specific orbits by using satellite launch vehicles. The functioning of the satellite launch vehicle is based on Newton's third law of motion. A specific type of fuel is used in the launch vehicle. The gas produced due to combustion of the fuel expands due to its high temperature and is expelled forcefully through the nozzles at the rear side of the launch vehicle. As a reaction of this, a thrust acts on the vehicle. This thrust drives the vehicle high into the space. The structure of the launch vehicle is decided by the weight of the satellite and the type of the orbit of the satellite. The fuel of the vehicle also depends on these factors. The fuel forms a major portion of the total weight of the launch vehicle. Thus, the vehicle has to carry a large weight of the fuel with it. To overcome this problem, launch vehicles with more than one stage are used. Due to this, the weight of the vehicle can be reduced step by step after its launching. For example, consider a launch vehicle having two stages. For launching the vehicle, the fuel and engine in the first stage are used. This imparts a specific velocity to the vehicle and takes it to a certain height. Once the fuel in this first stage is exhausted, the empty fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or on an unpopulated land. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. The vehicle now contains only one stage, that is the second stage. The weight now being reduced, the vehicle can move with higher speed. Almost all vehicles are made of either two or more stages. The structure of a Polar Satellite Launch Vehicle, that is PSLV, developed by ISRO of India is shown here. The lowermost part contains the engine using solid fuel, which provides the initial thrust. The PSLV contains 4 stages containing solid and liquid fuel systems alternately. That means the first stage uses the solid fuel, the second stage uses liquid fuel, the third stage again uses solid fuel, and the fourth stage uses the liquid fuel. The topmost part of the PSLV has a place to carry the satellite. The launch vehicles can be used only once and thus they are costly. Thus, USA has developed a space shuttle. Let us know about a space shuttle in brief. A space shuttle takes off vertically like a rocket, revolves around the Earth like a satellite, and lands back on the Earth like an aeroplane, after which it is repolished for reuse. A space shuttle has 3 main parts. 1. Reusable Orbiter Vehicle, that is OV. 2. The Expendable External Tank, that is EET. And 3. Reusable Solid Rocket Booster, that is SRB. This whole assembly is fired at a time. Within the journey of first 45 kilometers, fuel of the booster rockets gets over. They get detached automatically and start coming back towards the Earth. Parachutes attached to them open up and control their speed. They slowly come down on the Earth and land in the sea. Naval staff present there takes them out, and after minor repairs, they are reused. The space shuttle keeps going ahead with the help of liquid fuel rockets. After some time, the space shuttle attains the desired height. By this time, the liquid fuel tank has become empty, so it gets detached from the space shuttle, and while coming towards the Earth, it burns off due to friction. Then the space shuttle revolves around the Earth. If necessary, it is set in a proper orbit using 2 additional rocket engines. Later, the upper part of the space shuttle opens up for the release of the satellite by robotic arms. Once the satellite is launched in its orbit, the space shuttle returns to Earth. This means that, except the fuel tank, the space shuttle can be reused in multiple launches. Always remember, a type of firecracker known as rocket used in Diwali is also a sort of launcher. In this rocket, the fuel is ignited using a fuse and the rocket is projected into the sky just like a satellite launcher. Similarly, if a balloon is blown and released with its end open, the air in the balloon is forcefully ejected and the balloon is pushed in the opposite direction. This can be explained using Newton's third law of motion. Come, let us now proceed further to study about the space missions away from the Earth.